is Rod Johnson. Is that right?
Yes.
Okay. And can you give name and title first, and then I'll trim this part off.
Okay. My name is Rod Johnson. I'm the territory account manager for Xirrus in Texas and Louisiana is my territory that I cover.
This is Kelly Hill, technology reporter for RCR Wireless News. I'm here today with Rod Johnson of Xirrus, and we are going to be talking about Wi-Fi trends. Rod, I'm wondering if you can talk to us a little bit about some of the trends that you're seeing in Wi-Fi down in your area in Texas and that region.
Okay, well, kind of what I'm seeing today. So Xirrus as a company built a product, many years ago for high-density Wi-Fi. I've been selling this product for about 6.5 years, and my main vertical market that I've been working on has been education. And what we're seeing now is in the education space, all of the students have devices, sometimes one, sometimes three. You hear about one-to-one in the education space. We have several schools that have classrooms full of iPads. This brings a big problem to the Wi-Fi space, trying to get this many devices with a single antenna architecture on the Wi-Fi space. So the products that Xirrus has built, we have a multi-radio, we call it a Wi-Fi array. We go all the way from a 2 radio all the way up to a 16 radio array. So one of the trends that we're seeing in the classroom is we're seeing multiple access points from other vendors. From Xirrus, we're actually able to put in one, whether you want to put in 2 radios, whether you want to put in 4, or maybe you want to even put in 8. Basically, a radio equals a port, and that impacts how you architect the network. Most of our competitors are controller. That's what they have as their architecture, so all the data goes back to a controller, or they have some way to get it off of the APs. Our solution is actually controller-less, and we're more like a switch. So when you build the network, you build it more as a switch architecture instead of a wireless architecture like you would in the past. That helps us with 802.11ac get high data rates or high speed networking right on high speed data right onto the network as it's flowing. So that's kind of the trend that we're seeing today as a lot of devices, like with the iPhone 6 coming out. You're seeing tons of devices hitting the network. We're seeing that in the education space. We're seeing that in the LPV space with convention centers, stadiums, in the hospitality space with hotels. Everybody is bringing a device and they want it to be on the network.
Now, you mentioned 802.11ac. What are you seeing there in terms of the level of interest and deployment there?
Well, I think what you see in the networking space, I've been selling networking for a long time, and when new speeds come out, it's kind of like everybody wants it. They want to adopt to it as quickly as they can. We're seeing that in the AC space. The devices aren't quite there yet. Probably 85% of the devices are 11N, but you're actually starting to see some AC devices, like with Samsung Galaxy and iPhone 6, that are AC capable. So you are seeing more devices than MacBooks in the education space are AC capable as well. So most of our education customers, they want it today. Hospitality customers are kind of having that discussion whether they want it or not. They want the ability to maybe buy the product with that feature turned off and then add it later. The LPV space is kind of in the same situation. We just did a large deployment of a stadium in the southeast, it's SEC Conference Stadium. Last Saturday was the first go live. We saw mostly 85% 5 gig capable devices, but we didn't see a lot of AC devices yet. We probably only see maybe 1 or 2% AC devices at this point. But it's kind of it's new, it's exciting, and everybody will eventually adopt to it because all the devices will move that direction. It does have some nice features for not only speed, but also helps save battery life with your devices. So if you have an iPhone or something like that, the Wi-Fi network, the products or the APs supposed to help you save battery life, which is important to us. My battery runs down on my phone, all the time. So that's helpful.
What are you seeing in terms of 2.4 gigahertz versus 5 gigahertz deployments?
So when I first started with Xirrus, probably about 6 years ago, everybody wanted, only thing we really had was 2.4, and 5 gig was really, really new. But today, that's totally changing. As I mentioned that stadium, we saw 85% 5 gig capable devices. What's nice about 5 gig, so in the 2.4 space, there's only 3 channels available to us. It's basically 1, 6, and 11. And if you're trying to do a large, high-density deployment, you run out of channels really quickly. And if you have a 2 radio access point that has a 2.4 radio and a 5 gig radio, you end up turning 2.4 radios off. So when you buy that product, you've only really bought half of your usage. So with our solution, we actually do 5 gig on all of our radios, and it's software programmable. So it means I can adapt as the network changes. So if it's a lot of 2.4 today, we can deploy a nice 2.4 network, and then we can migrate to the 5. But actually what I'm seeing happening is most of the clients are 5, so we just need a few 2.4 radios available. So when we do a design, we only turn a few 2.4 radios on, and we turn most of the radios on in 5 gig. So that really helps because there's multiple channels in the 5 gig that we can use.
What about the impact on network design when it comes to 2.4 versus 5? In terms of the number of access points, capacity. Can you talk a little bit about how that's affecting the way that people are designing their Wi-Fi networks?
Okay, and the 2.4, it's basically half the bandwidth of a 5 gig radio, specifically because of channel bonding. You can't really channel bond the 2.4 when you only have 3 channels. If you're going to do a high density deployment, you're going to run out of channels really, really fast. You can channel bond in the 5 gig, which basically means, I'll use 802.11n numbers. A 5 gig can give you 150 meg of throughput, where we usually say 50 meg on the 2.4. So if you're going to design for 5 gig, then your uplinks on the access points need to be at a higher speed. So what we do, even on our true radio access point that we have, although it's AC capable, we do have 2 gig uplinks on our true radio access point. And then on our 16 radio array, we actually have a 10 gig fiber uplink. So when you design the network, you have to, like I said, you want to think of a Xirrus product as more like a switch. And so you want to design and architect a network more of a switch like you would with Ethernet switches that you have today. So if you're going to plug in a 16 radio array, you're going to need a fiber switch to connect that to. So it does impact the architecture of the network. Really what I do is it's kind of like a physics problem. I sit down with my customer and say, okay, how many devices are you going to have? How much bandwidth do you want to allow per user? And then we work the math, and that works back on what your uplink speed needs to be. Also works on how many radios that you're going to need in this environment, because a radio basically equals a port. So if you tell me you're going to have a 500-seat auditorium, then I'm like, okay, how much, we're going to give them sub dial-up speeds? Are we going to give them 1 meg? What are we going to give each one of these users that's going to be in this environment? And really a 3 meg connection is really what people want to get that response time that they're used to at home or work or wherever they're trying to operate their device. Much less than that, it starts getting into kind of jittery and timeouts and things like that. So you have to you have to plan on how much bandwidth you need. Even in the Wi-Fi space, since it's shared medium, you still have to do the math. And the more radios that you can put in, the better the solution that you're going to have.
And one more question in terms of some of what you're seeing in terms of trends and demands for aesthetics. As you're talking about places like, the large public venues, the schools, the even universities and places like churches.
Well, that's kind of a new vertical market that we've been kind of swimming in lately, which is churches. Which you walk into a nice church sanctuary, it is beautiful, and I have been in some. It's at the wood, and you got to figure out where can we put things, and so it is a challenge. We do have the ability to paint. We have covers that cover our device. You can paint them to match the cover of the ceiling or wherever you're putting them. We have outdoor enclosures that we've actually painted the color of the brick and put it on a wall, and this was actually in a school to please the drama teacher, because he was in charge of aesthetics in that auditorium. But what we've also seen, like in universities, I'm working with a large university in Texas. We did their Board of Regents conference room. It was all leather, all wood, but the Wi-Fi working took priority over the aesthetics. But then we also have products that we can put antennas on, that we can hide and put the antennas where we need them to be, and so that they won't be seen as much. In the stadium deployment that I talked about that we just did, we actually put the product underneath the seats, and we're actually covering just, I think, like 75 seats at a time with one access point. So it is tricky. You got to figure it out, and you got to talk to your customer and say, okay, where can we put stuff? I was just in a 3,300 seat church in Houston, and I said, can I put stuff on the walls? And the guy was like, no.
Yep.
And so it was like,
No.
okay, so, and it is better, like this convention center has high ceilings. It is better if we can bring the access points down closer to the people. Microsoft is one of our biggest customers, and their event group actually takes our 8 radio arrays and they put them in seats. So they will put them in a seat, they will cover it with black cloth, and then they put it within the people. And they've done 2,000 to 5,000 events that way. So there is lots of ways. If I was going to do, most of our convention center customers will bring our like rapid deployment kits, and they'll bring the arrays down to the level of the booths, and they'll do it that way, because putting them up high causes major problems with Wi-Fi. New Orleans Convention Center, it's the 3rd largest convention center in the U.S. It's one of my biggest customers. They actually put the arrays on chains and can actually lower them down depending on what kind of event that they have. So they use the seat architecture because they stole that from Microsoft, and then they put them on chains as another way that they've done events. And then they have our rapid deployment kits, so they can go in and adapt to the environment that they're trying to service.
Great, Rod. Thanks so much for your time.
All right, thank you.
And that's it. I'm sure.